So the year is 2021 and you're being educated over Twitch. I am Jacob Miller. Kahina already introduced me, but I'll do it again here for the recording. I've worked in the government my whole life. I've always been involved in surveillance. I've worked on nosocomial infections, sexually transmitted infections, vaccine preventable diseases, and drug use surveillance. I'm going to be spending some time trying to summarize the ways in which the government goes about collecting data for epidemiological purposes. Okay, so let's imagine that you are the government and you want to make evidence-based policy that will improve the population of improve the health of your population. I'm just looking at some comments real quick. Need an account to chat. Yeah, you'll need an account, so just type in Zoom if you can't type in Twitch. I'm watching Zoom as well. Okay, so how do you improve your population's health? Step one, collect data. That's a good start, right? We want evidence, and data is evidence. So I may be skipping a few steps here. Like planning, creating falsifiable hypotheses, crafting your methodology, and so on. But this talk isn't about scientific theory or experiment design. It's about surveillance. So let's focus on this plan of collecting data. So are there any problems with that plan, or is it always inherently the correct approach to say you want to gather data and then make policy based on that data? So I'm going to make the argument that no, it isn't always the inherently correct approach. And here are some reasons why. Not all problems are equally represented in data. So for example, let's say you're looking at some healthcare data and you see that such and such disease, you see such and such disease is not really a problem in your country. Okay, but what if there's a subpopulation that has reduced access to your healthcare system, and therefore they don't show up in your healthcare data? Well, the easy response to this would be, the solution is to get that data, fill the hole, collect more data, and move on to the next problem. Okay, so let's look at the next bullet here to see more relating to this. So, not all pieces of data are equally easy to acquire. So, in the previous bullet, I talked about how there may be a subpopulation that doesn't have access to your healthcare. So what if acknowledging that problem makes your government look bad? So it might be easier for people in the government making these decisions to sort of not acknowledge the problem. And it's very easy for these willfully ignorant to make the argument that the data says there's no problem. And that's a very easy argument to make. It's also possible that acquiring the data could just take a long time or cost a lot of money. So it's not necessarily correct to assume that once you spot missing data, it will be easy to acquire it afterwards. Okay, not all problems can be broken down to few enough variables to where data analysis is feasible. So some systems, especially systems relating to health, can be very complex. And sports are another good example of this. So let's say you want to know the correct way to pick up some weight or to do a specific lift. It's going to be very hard to get the answer to that through data. There are so many variables involved, and you aren't just choosing form A or form B. There's a million things going on in your musculoskeletal system of the body. There's also your history with fitness, your weight, your relative limb lengths might impact which form is better for you, your strength, your flexibility. So how could data analysis possibly tell you what you should do? That's not to say scientific studies can't possibly offer any value. Of course they could offer value. But the key is that as a scientist working on very complex systems, you have to simplify the problem you're trying to solve down to few enough variables that data analysis works. So that means that if you imagine like all the possible questions you could be asking, there is a limited subset which data analysis could actually support. because some of them are just too complicated to answer through that sort of analysis. And finally, when you worship at the altar of data, you bring a bias towards existing solutions. Existing policies are the ones for which there will be the most data available. If 3 other countries have tried 3 different solutions, it's very hard to make the argument that you should create a 4th unique solution. It's much easier to argue that you should pick the existing solution for which the data shows the best outcomes. And that's not inherently a bad thing. In fact, that can be a very good thing. However, it sometimes is the case that all the existing solutions suck. And I'm just pointing out that if that's the case, it's very hard to make that argument because you're pitting you're pitting your reason up against data, and that's an uphill battle. Okay. Nevertheless, science is the best problem-solving tool humanity has ever developed. So if you're collecting or using data, you are, in fact, probably on the right track. All right, so let's get into the meat of this presentation. How does the Canadian federal government source data for surveillance? I typically see people divide surveillance into passive and active. Passive can be thought of as ongoing data collection from sources that would exist regardless of the activities of the surveillance people. For example, hospital data. Hospitals would be collecting records regardless of whether or not surveillance people in the federal government wanted them to. Passive surveillance is cost efficient. It casts the widest net and gives the highest probability that at least some information is available to those studying a given subject. Nobody making policy relating to gonorrhea would neglect to look at and cite gonorrhea rates across the country. The clearest example of passive surveillance I can offer is surveillance of nationally notifiable diseases. In Canada, there are 70 or so diseases that are classified as being nationally notifiable. This means that existing healthcare services are mandated to report whenever they diagnose a notifiable disease. Data is collected at the local level and passed up to the provincial and national level. Passive surveillance generally has a time lag, especially if the data has to pass through multiple hands before reaching the federal government. There can be a year or more than a year of delay between the data first being recorded and the data being analyzed and reported. The third point I have here, it really varies for each surveillance system, but the data set can be quite limited for this type of surveillance. The reason for this is that the design of these data sets can be highly compromised depending on the realities of all the parties involved in collecting and passing along the data. You don't want to ask an overworked nurse to fill out page after page of administrative information. And there are also ethical considerations. For example, you can't ask for information that could potentially identify someone. Independent parties involved in your passive surveillance are going to have distinct methods for collecting data. And these methods will be influenced by historical precedent within their region. So if you're working with a bunch of different hospitals, you can't assume that those hospitals, you can't assume that the employees within those hospitals are going to be following the exact same practices in filling out the data. And when you're working with many different partners, you also have to acknowledge that the different partners have different capabilities. And this could be technological capabilities, or this could be just manpower, or how many hours they have available for the task. So they're all going to have different capabilities. And when you're designing a surveillance system and you're coordinating with provinces or territories or hospitals, sexual health clinics, and so on, you need to request the version of the data set which they will all agree to fulfill. And you want consistent data, you want them to all be able to do it, so you kind of end up with the lowest common denominator. Whatever the lowest performer is able to provide is sort of, that's the standard data set that you're gonna be able to get. Like that's the information that they're all gonna be able to fulfill. It's gonna be determined by the weakest link. Um, so all these issues that I just listed have an impact on how the final data set will look and what kind of analysis it will be capable of supporting. When you're looking at data at this level, like the level you typically get out of passive surveillance, you're unlikely to spot community level issues, right? You do have data at the federal level, probably aggregated to a provincial level. So an outbreak in one small town, for example, just isn't going to show up in this data. Okay, and then of course we have active surveillance. So active surveillance involves people specifically employed for the purpose of collecting data tailored towards analytical purposes. This is faster than passive surveillance and more actionable at a local level. It also takes more resources. So for the rest of my presentation, I'm going to be going over different surveillance systems that the federal Canadian government uses. And I'm not going to tell you whether each of these falls into the category of passive or active. In fact, I don't think you'll really find people think in these terms when doing surveillance in the Canadian federal government. The reality is that as an employee of the federal government, you're almost always going to build on existing infrastructure when some exists. Almost every surveillance system, therefore, is a mixture of passive and active components. So to give an example to illustrate this, let's say you have existing hospital data. You may provide them funding in return to get that data. And perhaps you also provide some funding that goes towards a percentage of the employee's time being devoted towards data collection, or a percentage of their time being devoted towards training. So it's a passive system, but you've implemented some active components because it is no longer just a system that would exist in that state regardless of the surveillance. The surveillance is in fact having an impact on how the data collection system functions. You might choose to use an existing source of data, like a passive source of data, but you could have an expert working group evaluate the data that's being collected and the practices involved in that collection, and then potentially use that working group to revise those practices. So again, there is that active component of people influencing the data collection and so on. So there's a wide spectrum of surveillance systems and a large variety of ways in which active surveillance can be incorporated into them. All right, moving on to administrative data. So this type of data represents one of the most commonly used sources of data in Canada. Why? Because it's the easiest to collect, right? The data is widely available, so it is inherently widely used. This source of data is generally collected not for the purpose of research, but for record-keeping purposes for the respective institution's needs. However, it is often the case that the data that's collected can be altered to some extent to accommodate the needs of the researchers. That's sort of what I was just talking about with the mixture of active and passive components. But I will say that the alterations that take place, whatever, is always going to be a secondary consideration that comes before the needs of the institution that is collecting the data. As a researcher using administrative data, you almost always have to compromise on the analysis that you can do. The data has not been fit to your purpose, so you have to adapt to it. When looking at administrative data collected by many participants, there's a large amount of variation in data collection practices. If you're looking at hospital data, you have to remember that different hospitals are going to have different admission practices. They're going to serve different populations. They're going to have different data recording practices and so on. And even within one hospital, you could have different practices between the different staff. And I want to give an example here of administrative data, but rather than talking about the obvious examples that are listed there in the first bullet point, I'm going to talk about enhanced surveillance of gonorrhea. So in Canada, gonorrhea is a notifiable disease, and therefore the Public Health Agency of Canada will automatically get case counts on an ongoing basis. However, antimicrobial resistance is something they want to track, And that's not something that is included in the Canadian Notifiable Disease Surveillance System. There's nothing on antimicrobial resistance. Therefore, to get this data, the Public Health Agency developed a project called the Enhanced Surveillance of Antimicrobial Resistant Gonorrhea. Sexual health clinics in Canada already had an infrastructure to have urine or a swab collected from patients and subsequently test it through urine analysis or culture growth. Urine is easier and faster, but you can't do resistance testing on a urine sample. Through the Enhanced Surveillance Initiative, the federal government worked with selected clinics and the National Microbiology Laboratory to have more swabs done, so more cultures could be grown, so as to facilitate more antimicrobial resistance testing. To make this possible, testing capabilities were supplemented and some culture rerouting was done. So if a clinic did not have the ability to have their cultures tested within the province, then they were given the option to send those cultures to the National Microbiology Laboratory. The clinics were given the support in order to generate the more valuable data. So I don't actually know where this project currently is. It's been years since I worked on it, and perhaps it's lost in a tangled web of bureaucracy. But I hope it succeeded, and I hope it's still in use. It's hard to say in the government sometimes why some things fail and why some things succeed. But the reason I hope it succeeded is that this enhanced surveillance network pushed gonorrhea surveillance to something that was designed to support research and something that produced highly actionable data. A dendrogram showing the evolutionary development of different strains of gonorrhea could be produced. We could identify where resistance was introduced, where resistance to different antibiotics was introduced. This could be used to support robust contact tracing. And the faster urine analysis was still performed often, and it also benefited from this program. The reason for this is if you have a urine sample from a patient, you can still do nucleotide sequencing. So you can determine if gonorrhea is present within that urine sample, you can determine the nucleotide sequence of that gonorrhea. If a culture has been tested that had the same or a similar nucleotide sequence, then you could do your antibiotic testing on that culture. Then you can infer the resistance pattern from the culture because the nucleotide sequences are the same. So this project offered a lot of value to all participants. And another way it offered value is that the network that was built allowed experts from across Canada to discuss and exchange their best ideas, experts that might not necessarily have otherwise communicated. So I bring this project up because I think it serves as a very good example for all of us involved in routine surveillance of administrative data. Federal surveillance is at its best when you actually know what every row in a database means, when you have some interaction with every party in the chain, and when you have a consistent methodology across data collection partners, and when you've actually reduced your limitations to a manageable level. And that last point is very important because I find with administrative data, the list of limitations is often so long and so significant that you're basically free to dismiss the data whenever you want. And you can just include it as a supporting argument whenever the results happen to align with your expectations. There's a large disconnect between analysts and the people collecting data. Often the analysts could not even tell you exactly where the data comes from, and the people collecting it aren't even aware that analysis is taking place on that data. Okay, moving on from administrative data and on to two lesser used sources of data here. I'm not sure if these are universally lesser used or if that's just Okay, 5:30. People should be getting back now. I'll just get everything prepared while I give everyone a minute or two more. Also, I'm not wearing my headphones anymore, so if you say anything in Zoom, I won't hear you. So just use the text chat. My Overwatch main is McCree. If you look at my Twitch profile, you can probably see videos of me dying. All right, so I'm ready to go ahead. I think I'll get started on this. So, no problem. Why bother learning Python? You do not need to learn Python to get through your career in epidemiology. You don't need Python to work in the federal government doing epidemiology. So why bother? I would say learning coding beyond statistical software, so beyond SAS, learning coding is going to open up a lot of opportunities for you in the government. The reality is, this world where everything is computers and shit got thrust on us very quickly. Code is how you make computers do things. And no matter where you work, pretty much if you know how to code, you will be able to offer value that other people are not going to be able to offer. I've never worked anywhere where I didn't feel, okay, put it this way. I have a general bachelor's of science. It's a 3-year degree at U Ottawa. And I started in the government at just the lowest position possible. And the only reason I got rehired, the only reason I got opportunities throughout my career really is because of, well, first it was being good at Excel. Being good at Excel is important, but after that it was coding, because it just doesn't matter where I go. I can offer a lot of value just through being able to do programming. I can just speed everything up, especially when it comes to data cleaning. Data cleaning is such a pain in the ass. And to give you, okay, for example, like I worked somewhere where they got data through emails. Excel files were emailed from like 50 hospitals. Kane and she used to work there too. And like, yeah, imagine working in 50 Excel files manually. No, no. So like, if you're familiar with a for loop in programming, all you have to do is write for each of these Excel files, do some task, and then that's so much faster. Is Python similar to R? So yes, for the world of data analysis, for the world of statistics, Python and R are both valuable. They're both good choices. They're both good. So I've never found anything that I could do in one that I couldn't do in the other. I think R has, I think more people in stats and more people, yeah, in that area use R. So like by all means, R is a great option too. But I know Python, so I'm going to be covering Python. But R and Python, they're both free. They're both relatively easy to pick up, and they both have huge user bases. So that's why these two languages are very advantageous, because they have massive user bases, and you cannot understate the value of just being able to type an error verbatim into Google, or just type generally like your problem into Google, and then to have like a ton of discussions available to you where people are discussing the exact issue you're working on. That's so valuable. And Python and R are they both have large enough user bases that there's a ton of support online essentially for learning them. So I think no matter what you do in your career, you will almost definitely get value out of learning programming. But it is a fair amount of effort, and you have to decide if it's worth it for you. But yeah, I'll be covering. So actually, initially, I wanted to do a Python workshop where I would have you guys write some code and run it during the class. But I realized this wasn't really feasible from a time perspective. So if you look online, you'll find dozens of Python courses that lay out all the fundamentals, and they walk you through a bunch of exercises, and you like do this over several weeks. But I don't have weeks, I have like an hour. So what's my approach here? Because I said I'm not doing like the workshop where I have you guys run code. So when talking about the craft of writing, Stephen King said that a writer's skill can be thought of as a toolbox. And the toolbox has several drawers. The first drawer is vocabulary. You don't need a big vocabulary to be a good writer, and you don't need a big vocabulary to write good code. But every action you take as a writer or as a programmer is going to be done on the basis of what you have in this first drawer. So I want to take this hour and just jam pack as much as possible into your vocabulary drawer, into your Python toolbox. And what I'm hoping, my belief is that from there, after going through this hour with me, you will, when you go forward, whatever you do in Python, hopefully you will think back and you will say, yes, I've seen that. I know how it works. I've seen a working example of this thing. And you'll have a lot of the fundamentals in your brain tied together in some structure that hopefully doesn't disappear once this hour is completed. Okay, so one final note on sort of advice I have for learning Python going forward. You sort of have two basic options. So your first option is to find a course to follow the course. So that's sort of the typical way to learn something. You start with the foundation, you build up from your foundation. And the second is look up how to do a specific task. Find perhaps a guide telling you how to do that specific task, or figure out how you can break that task into smaller parts and then Google how to do each of those. And I'm hoping that after you see some of this code that I'm going to be going through, that will seem like a more reasonable option. I'm hoping that you will think of things that you could reasonably look up how to do with the 1 hour of knowledge I'm going to be giving you. And so like this idea of like doing a course or looking up how to do a task, it's sort of like the way I would think of it is you could take a woodworking class, or you can just Google, how do I build a chair? So the woodworking class will give you the more robust foundation, but it's more effort and it's more commitment. It's not as fun. If you just go buy some wood and you follow like a 1-page guide on how to build a chair, that's probably more fun. And whatever. Why? I don't know. The thing is when you're learning, a lot of people, I think you imagine that you'll stick to a program or whatever, and then you drop it. And the reason is it's not fun. And if you make learning fun, then you're more likely to stick with it. So there's pros and cons to both of these approaches. Hopefully, once this is done, if you want to learn Python, you'll have some idea of which approach is going to work for you. And the other thing is, I'm not going to have time to help with troubleshooting during this period. So I recommend you do your best to listen, take notes as you see appropriate, and you have the GitHub with the files. Kahina will share this video with you. Like I'm going to share the video with her and she will upload it. I'm also going to be uploading this video to my YouTube channel so you can review it afterwards. And with regards to issues you might have with code or with installing Python or whatever, you're free to email me troubleshooting questions after this presentation, but please do try to Google first. Normally, if you just literally Google the exact error you're getting, like if you try and run Python, you Google and it doesn't work. If you Google the error you're getting, you will likely find relevant information. Okay, let's get on with this. So, what am I looking at? This on the left is Notepad++. So Notepad++ is a simple text editor. And Notepad++ is sort of my preferred environment to code in. So you can write Python in any text editor. And there are also programs that are designed for writing Python inside of. So I'm just going to introduce Python to you through a text editor. And if you want something beefier that does more for you, you can look into that later. So essentially, this text editor, all it's going to do is highlight like Python keywords. You don't have to download it. I recommend it. I'll share the link with you later. I recommend it, but you don't have to. You can write Python in any text editor. How do I get the white screen? I don't know what that means. Could you clarify that question? Yeah, we are going to be working from the terminal. Yeah, my YouTube is Melon Face Doom. It's the same as my Twitch. Okay, so Notepad++ highlights keywords. It highlights Python keywords in blue. So import is a Python keyword, and print is a Python keyword. Can I use terminal on Mac? Yeah, there should be a terminal on Mac as well. I'm not familiar with Mac. You'll have to like Google how to use the terminal on Mac. I have black screen. Are you saying you open Notepad++ and it's black? As I said, I'm not really going to have time to. I'm not going to have time to do a ton of troubleshooting because I have a ton of stuff I want to get through. So, but like if you can't get it running right now, it's not important. So like I said, I would just suggest listening, and then in terms of like actually coding and running through stuff on your own, I would do that after because we're not going to have time to do that during the class. Okay, so the first line here is an import statement. You import packages in Python with the import keyword, followed by the package name. So pandas is the name of the package. We import that with import pandas. Then the second line uses the built-in print function to print the text that is within the parentheses. So the text here has to be inside single or double quotes. So in this instance, the text is in double quotes. We could replace these with apostrophes, single quotes, and that is also a valid string. But I'll just leave it as double quotes. Okay, so this is a 2-line file. We want to run this, and to run this, we're going to use the terminal. Oh. Okay, so this is the Windows terminal. If you're not familiar, you might want to look up the basics on how to use it. I honestly only don't know the basics because I pretty much only use it when I'm doing stuff with Python. But I know enough that it lets me use Python when I want to run files directly. Okay, so I'm going to try and cover some basics of how to use the terminal here, how you can browse through files and so on. So the terminal always has a working directory. In this case, mine defaults to C users Jacob. If I want to run Python files that are in a different folder, then I need to move to that folder. In this case, the files are in a different folder, so I'm going to have to move to a different folder. And that is done with the cd command. cd stands for change directory. So in this case, I happen to know where my files are. And what I was just doing there was, if you type the first letter of a file or a folder, and then you press tab, the terminal will auto-complete it for you. So if you see words just appearing, it's because I've typed like the first letter or the first few letters, and then I press tab, and then the terminal auto-completes it. So I am going to change directory to where I know my files are. And another useful command in the terminal is the dir command, dir. So if you type dir and then you press enter, it is going to list the files and folders that are within the folder you're in. So there's a bunch of, essentially there's a bunch of Python files here and a few other things. Okay, so this is the folder I want to be in. This is the folder with my Python files. There's another way you can get to any folder through the terminal, and that would be, let's say you're not very comfortable with the terminal, and you want to use your Windows browser to sort of get to the location. Okay, so sorry, you can't see this right now, but in a different window, I've opened Windows Explorer. I browse to the folder where I know my files are. And then what I can do is if I just type cd and then I paste the full path, you see this is the full path that I've just copied from Windows Explorer. You could also do that. And I'm already in there, so it's not going to change the directory, but I could have been anywhere and then typed that and it would put me in the folder. So if you're not comfortable with sort of using cd and whatever to get to a file location, you can also just open Windows Explorer, get to the folder, copy the path, and then type cd space, and then paste the path. You can paste the path with Control V. Okay, and there's one other thing. If you type cd ... it will go up one. So see, I was in this folder, and then I was in a subfolder, and then I typed cd ... and it put me up one. But so that's also a useful command. I'm going to go back here. So now I want to run the file. How do you run a file? You type Python, assuming you have Python installed, and then the name of the file. So Python hello world. It took a moment to import the package. And then once the package was imported, it printed the line, hello, looks like Pan is installed correctly. And I'll just show you what would happen if I wrote the name of a package that does not exist. It would say module not found error, no module named, and then the name of the incorrect module. So that's an example. That's an example of an error message in Python. It tells you the line where the error occurred. In this case, the first line is that import line. And then it gives you a little information about the error. Okay. Now we're going to move on to the next file here, iteration.py, and we're going to actually start learning Python. When you run a Python file, it scans it from top to bottom to find syntax errors. If there are any syntax errors, it will tell you about them before it actually runs the code. If there are no syntax errors, it will then run the code from top to bottom. I'm going to go through each line of code here and explain what Python is doing when it encounters that line of code. So first, I'm declaring two variables in these first two lines. In my first line, I'm setting some numbers equal to a list that contains 3 integers. In the second line, I'm setting my name equal to a string that says Jacob space Miller. So in Python, you use the equal sign to declare or to set a variable equal to a value. And you may have seen in other languages, you need to specify variable type. In Python, you never need to specify variable type. So it is going to know the type based on what you are setting it equal to. So in this case, this is a list. It's just going to make this a list. So I never had to say, like in other languages, before you did this, you would have to say, we're creating a variable called some numbers. We're going to set it to the type list, and then you could provide it with the list. In Python, you define the type by providing it a value. So here we provide a string, so it's going to make this variable string. There's nothing else you need to do. At the end of each of these two lines is a comment, which is denoted by the number sign. So anything after the number sign is going to not be code that is run. It is just text that you can read. It's a comment. What happens if you had a mix of numbers and characters? Good question. So actually, I don't know if you mean within the list or within the variable name. So I'll talk about the variable name first. So variable names in Python, they have to start with a letter. There's certain special characters they can't contain because Python thinks they're operators. For example, plus, if you wrote plus, it would try and add two variables together. It would try and add some underscore to a variable called numbers. Actually, it's not true that they have to start with letters. They can start with underscores. There's probably other symbols they could also start with, but they can't start with numbers. So if you try and start a variable name with a number, if I try to run this, it says there is a syntax error, and it points to the variable where the syntax error is. So the error here is that I put a number at the start of the variable name, and that's not valid. You can put numbers inside of it or at the end of it, but not at the beginning. So as for, I think you actually meant what if there's numbers and characters in a list? You can do that. You can put anything you want inside of a list. It doesn't need to be of one type. It can be as however many types as you want. So yeah, so if you put strings in addition to numbers inside this list, it would be valid. Okay, so some more quick notes about syntax. The spaces here do not matter. You can remove these spaces and it will run fine. You could add a space here or here and it'll run fine. But, you can also add lines in between and that will run fine. But you cannot add spaces to the start of a line. And I'll run this again to show you what it's going to look like. It's going to return an indentation error and it's going to say unexpected indent. So the reason for this is Python uses indentation as part of its logic, and this will make more sense soon, but for now just know that indentation at the start of lines matters. It doesn't matter if you put indentation or spaces in a blank line. Blank lines are just blank, they're nothing. So it'll ignore blank lines. So like you never have some mystery space somewhere that's breaking your code. It'll only break your code if it's actually changing a line that has code in it. Okay, so that covers the first two lines. I'm going to move on now to lines 5 through 10 here. Well, line 4 is just another comment. Line 5 through 10 is a dictionary. So dictionaries are declared using curly brackets, and they consist of pairs of keys and values. So you see there's this syntax here where there is a string, then there's a colon, and then there's another string, then there's a comma. Okay, so what we're seeing here is the pattern of key, colon, value, and then comma allows you to put another one of these pairs. So here's another key and value. Oh, this is Alfred Hitchcock. Sorry, sir. So interstellar is a key that corresponds to the value of Christopher Nolan. Rear window is a key that corresponds to the value of Alfred Hitchcock. And you're probably thinking, what does this mean? Why would you do this? I'll show you how to use a dictionary soon, but for now, just try and understand the syntax. Each line here is a pair, where the first value corresponds to the second value. You add more pairs by putting commas. And you don't have to put a new line for each of these. You could have put them all in one line. It's fine, but it looks prettier if you do this. And the indentation here doesn't matter. This indentation could be, like the indentation inside of these curly brackets can vary. But again, it looks nice if you do it like that. Okay. I'm hoping that as we go through this and you just see examples of where indentation does matter and where indentation doesn't matter, I'm hoping that you sort of gain an intuition for how to use indentation in Python. Because I don't want to just like give some big 10-minute spiel on here are all the cases of how indentation is used in Python because you'll zone out 2 minutes into that. Okay, so lol. Lol is a list of lists. So if you remember at the top, we had a list. In the first line, there's a list with 3 elements. See, square brackets is a list. Here we have square brackets again. Inside of this list, we have more square brackets. What this means is that the elements within the big list are themselves lists. Because remember what I said after Kahina asked her question, I said, you can put anything in a list. You can put lists in lists, you can put dictionaries in lists, you can put anything. Okay, so each of the interior lists has a length of 2, and each one contains a string and an integer. So they don't have to be consistent. This one could have been only integers, this one could have been only string, this one could be length 3, this one could be length 10. It doesn't matter. There's no rules. There's no rules. So they just happen to be nice and neat like this, but they don't have to be. And often the flexibility of lists is really nice. And spacing here, where does spacing matter? It doesn't. You could put spaces all over. Although the space inside of a string here does matter, because if I were to put a space here, you would have a string of length 2. The first character in your string would be a space, the second would be an A. And that's different from just a string that's equal to A. But these spaces don't matter. Okay, I'll move on. The next chunk of code here, you see all this pink, this blue and pink. So the pink is Notepad++ highlighting functions as they are defined. So in Python, you define a function by using the keyword def, followed by the name of your function, followed by parentheses, and then a colon. The code that corresponds to a function is defined by the indent. So Python sees this line is indented, this line is indented, and this line is indented. Therefore, these 3 lines of code, and then it goes here and it sees this one is not indented. So it knows the code that corresponds to this function has ended, right? In other languages, you might have like parentheses that wrap the entirety of the code that corresponds to a function. And that's how the programming language sort of uses the logic to determine what code is corresponding to a function. In Python, there's nothing like that. There's no like end function statement. It's just when it encounters an unindented line of code, it's going to say, this is not part of the function ended line before. And the blank line is ignored. So the blank line isn't part of it. The blank line, an unindented blank line would not end the code. So let's say I had, more code here. So this unindented blank line, it doesn't matter. It's not going to end the function because it sees this. It's going to see the indent here. This is part of the code. See the indent. This is part of the code. Indented, part of the code. Blank. It ignores it. It sees this is indented. It's going to consider it part of the function. A blank line again is going to be ignored. And then this unindented line is where it's going to say, okay, we're no longer dealing with the function. Okay, so for now, don't worry about what is within these functions. We'll be exploring them one at a time in a moment. What I want to say is that, like I said, Python is going to be interpreting this one line at a time from top to bottom. When it gets to line 14 here, it's going, and this function is defined, it does not actually run this code. It only remembers it. Later, when we call the function, it will run the code. And this is handy because the way you should be using functions, well, I don't know, there's a lot of different, I guess, philosophical approaches, but functions can be useful if you have some section of code that you know you're going to repeat many times in different places. So like, let's say there's some, statistical test or whatever you're doing that returns true or false, and you're going to call it in a bunch of different places. You put that code in a function, and then later you can call the function without rewriting those lines of code. Okay. So Python, as it reads through these function definitions, it is not running any of this code. It is only remembering it for later. So I'm going to skip over this for now and go down here. So in the last lines of code here, we have function calls. So this loop through list and then two parentheses, loop through list was the name of the first function. This is how you call a function in Python. You write the name of it and then you write the parentheses. Yeah, okay, so let's run this and see what happens. So, okay, the other thing is, each of these lines here correspond to one, oh, why is this not in order? Each of these correspond to one of the other functions, and they're commented out, so these lines won't run. So Python will run through the whole thing. This is the last uncommented line, so this is the last thing that will run. So let's try it and see what we get. It prints 1, 2, 3. Why does it print 1, 2, 3? Let's look at the function and see what's happening. So what I'm introducing here is this concept of a for loop. If you use any other programming languages, no idea what your backgrounds are. Maybe you've done some things in SAS that involve a for loop. The for loop is like the most basic, probably most common thing you'll use. Maybe, I don't know. But it is very common and useful. So you'll notice, okay, so let me go through the syntax of how you format a for loop in Python. You write for, and then you introduce a new variable name. In this case, thingy is my new variable name. Then you write the keyword in, and then you write something that has sub-elements. So what I'm writing here is this list. We know this list has 3 elements. Forget the word sub-element. I don't know why I said sub-element. Let's just say element. So this list has 3 elements, some numbers, and we are looping through this list with 3 elements. So what that means is that Python is going to run through the loop one time. It is going to set thingy equal to the first value in the list, which is 1. And then it's going to do some code. Then it's going to go through the second loop. On the second loop, it's going to set thingy equal to the second value, which is 2. And then it's going to do some code. And then the third loop is going to set thingy equal to the third value, which is 3, and do some code. So what code does the for loop do? The for loop does all the code that is indented. So here we see an indent. Here we see not indented. So the for loop knows this is part of my loop, this is not. So if you remember in the terminal, we saw it printed 1 and then 2 and then 3. That is because thingy was set to the first element, 1. The single line of code here was run, which prints the value of thingy, which is 1, so it prints 1. Then it's going to go through the second loop, and I've already done this, so you know what it does. It's going to print each element one at a time as thingy is set to the values inside of the list, some numbers. Okay, now let's comment that, and let's uncomment this. And by the way, I'm saving the file. I'm pressing Control-S to save the file every time I'm doing this. If you don't save the file, it's not going to know what you're doing. Okay, so I've saved the file. Loop through string. So this function is now going to be called. Let's run it and see what it does. It writes JACOBMILLER, all one at a time. So okay, so what's happening here? This is almost the exact same format as before. Instead of writing thingy and some numbers, though, I've written character and my name. So for character in my name is the thing that is being looped over or iterated over. So if we look up here to see what my name is equal to, it is equal to Jacob space Miller. A nice thing in Python is that strings are basically lists that contain each of the characters in the string. So just like you can do a for loop with a list, you can do a for loop with a string. So on the first loop, it sets character equal to J. On the second loop, it sets it equal to A. On the second loop, on the third loop, it sets it equal to C, and so on. So it's going to run this single line of code here, print character, for every character that's in the string. So this just demonstrates that you can loop over strings. Okay. Third function here, use dict. So as I said before, I'm going to show you in more detail what a dictionary is. There's a single line of code here. It just says to print movie directors, then we see square brackets, and then a string. So before I said square brackets are used when we are defining lists, they're also used for indexing. So if you see elements in square brackets like this on their own, that's a list. If you see back down here at line 25, if you see square brackets butted up against something else, then those square brackets are being used to index that thing. So there's different ways to index different variables. But we're covering dictionaries right now, and this is the way you index a dictionary. You write the name of the dictionary. In this case, we set movie directors equal to this dictionary. So movie directors is the name of the dictionary, so you write that. Then you write square brackets, and inside the square brackets, you put a key. So remember I said there are keys, back up here where I've defined the dictionary. There are keys that correspond to values. So you can index the dictionary on any of these 4 keys. In this case, I've written Mad Max Fury Road. So let's see what it returns. It just printed George Miller. So Mad Max Fury Road is a key that corresponds to the value of George Miller. When you provide it with the key, it gives you the value. And that's not true in reverse. So if I wrote George Miller here, you'll see there's a key error because George Miller is not a key. Only the values to the left of the colons are keys. So these 4 are keys. Yeah, so that's how dictionaries work. You provide keys and values, and if you input the key, you can get the value out. Okay. lol1. So here is the function lol1. I'm just going to go ahead and run it. And let's take a look at it, and let's look at the values side by side. So for pair in lol, so remember, lol is the list of lists. So we're saying we're going to loop through each element in this list of lists, and we're just going to print it. See, it says for pair in lol, print pair. Everything else is commented. Indentation on comments don't matter, by the way, so it could have been anywhere. I think the proper way is to indent it, I think. Doesn't matter, it's just a form. Okay, so the comment I have here just says, don't use list as a variable name since it's a Python keyword. So because this is a list of lists, it might seem natural to write for list, for list in lol, but that would be bad practice because list is a Python keyword and you don't want to set variables equal to Python keywords. For example, def, you wouldn't want to set a variable equal to def. So I've just written pair instead of, yeah. So for pair in lol, print pair. So what is it printing each time? First it prints A1, B2, C3. Each time it printed them in square brackets. Why is it doing that? It is doing that because the 4 elements of lol are these 4 lists. So on the first iteration, it set pair equal to this, and then it printed it. And then the second iteration, it set pair equal to this, and then it printed it, and so on. So what if we wanted to access the individual elements within these lists? There's a lot of ways to do it, and I'm going to cover 2. Oops. Okay. So first of all, let's look at this code here, line 35 to 38. It's a function called lol2. We have the same opener for the for loop to loop over lol, for pair in lol. And then inside of that for loop, I have another for loop. So I can put another for loop in here because I know on each loop of the main loop, pair is going to be equal to a list. And lists are things we can do for loops over. So on the first iteration, pair will be equal to a comma 1. And I can say for item in pair, print item. And let's see what that returns. It's returning each element one at a time, because if the first time pair is equal to a comma 1, and then we say for item in pair, item will first be equal to a, and then it gets printed, and then item will be equal to 1, and then it will get printed. And then it's going to return back up here for the second main loop, where pair is set to b comma 2, and then we do the for loop on that, and so on. So essentially, we have a nested for loop here. The first one, so the main one runs 4 times. Within each iteration, this for loop is going to run twice. So this thing runs 8 times in total. And that's a nested for loop. Okay, so let's look at another example in lol 3 to see a different way we could have accessed those individual elements within each of these 4 interior lists. So this is new syntax you haven't seen yet. It says for a comma b in lol. And let's run that and see what it's going to print. It's going to print a is a letter and 1 is a number, b is a letter and 2 is a number, and so on. So I have a second new concept here, which is called an f string in Python. So you see this is a string, the area I've highlighted there. And if you precede a string with an f, then it will be an f string instead of a string. And what that allows you to do is you can use curly brackets inside of your string to put code. In this case, the only code I'm putting are variables. I'm putting the variable a here, and I'm putting the variable b here. If you had integers, you could have put like a variable times a number or something. But I'm just going to keep it simple. I'm just putting the variable name there. But you can, like I'm trying to say, you can kind of put any code, or you can put any code inside of these curly brackets. Although it would be very ugly if you did like a long line of code. So this is an f string. So we have a in curly brackets and b in curly brackets. What that means is that instead of writing curly bracket a, it's going to evaluate whatever this code is, and it's going to print that instead. So what's a equal to and what is b equal to? Well, the for loop here says for a comma b in lol. This is a for loop that is going to iterate over lol. Lol is a list of lists. It has 4 sub-elements. Each has length 2. So before I said lists do not have to have sub-elements of the same length. It's valid to have a list in Python or a list of lists where one element is length 3, one is length 2, and so on. But if they are the same length, here is something you can do. Since you are expecting 2 values every time, if you write some variable, comma, some second variable, then it will set the first variable equal to the first value, and it will set the second variable equal to the second value. So on the first iteration, it is going to say, we are encountering the first element of this list, that is a comma 1. If I say, I should have used different variable names. So a, this is just a string, this could be any string. I didn't write a there and a here, so they're the same, it doesn't matter. Okay, so so we're doing a for loop on lol. We're going to the first element. First element has 2 elements. And when we say for something comma something, it's going to set the first variable equal to the first value, and it's going to set the second variable equal to the second value. Okay, so what would happen if we did have a list with extra elements? So this interior list now has 3 elements, whereas the others have 2. What happens if we try and run the code? It's going to say, there was a value error. There were too many values to unpack. It expected 2. It expected 2 because I'm giving it, because I've written two values here, or 2 variables here. So I'm saying set the first variable equal to the second, set the first variable equal to the first element, set the second variable equal to the second element. And when Python encounters this list of length 3, it's saying, well, what do I do with the third element? You have to be specific in this case. And if it encounters a list with the wrong number of elements, it will not be able to execute this code. Okay. So now I am going to introduce a while loop. So I have a function called while loop. And then inside of that function, I have these indented lines. So those are what is the function. First line here, I have a equals 100. Then while a is greater than 75, colon, print a, and then a minus equals 12, and then print a is now equal to, or a is now something. So let's run this and see what happens. First it prints 100, then 88, then 76, and then it says a is now 64. So why does it do this? So first we set a to 100, and then we got into the while loop. So how is this while loop working? Again, just like the for loop, the while loop consists of the indented lines of code within it. So in this case, there's 2 lines of code. The first line of code says to print a. Second line of code says a minus equals 12. A minus equal 12 is equal to, it's equivalent to saying a equals a minus 12. So it's just going to take the existing value of 12 and subtract 12 from it. Sorry, it's going to take the existing value of a and subtract 12 from it. So when does the while loop stop going? The while loop stops when this condition is no longer true. So every time the while loop runs, it's going to check this statement, and it's going to determine whether or not it's true or false. At the very first line here, we set a equal to 100. Then we're running a logic test here, a greater than 75. Since 100 is greater than 75, it will return true. Then it will keep looping through this, and at the end of every loop, it's going to go back to the top, and it's going to run the test again, and it's going to say, is this true or false? So once a is less than or equal to 75, this will evaluate to false, and this will not run. So that is why in the terminal we see 100 was printed, the original value. 88 was printed, that's the first time 12 was subtracted. Then 76 was printed, 12 was subtracted again. And then, oh, I see, okay. Whoops, I should have done this the other way, doesn't matter. Okay, so, and then it says a is 64. So what happened in between? So it went through, it printed a as 76, and then when it subtracted 12 from 76, the value became 64. Then this was tested again. A greater than 75 evaluated to false because a was 64 at this point. So this never ran. So that's why the last thing that was printed is 76. Yeah, because once it was 64, this evaluates to false, so this does not run again. Then the for loop is completed, it moves on to the next line of code, and it's going to print a is now 64. So while loops recheck the condition at the top of each loop. If the condition is met in the middle, for example, let's say we did a bunch of adding and subtracting whenever. If a became less than 75 in the middle here, and then something was added to a and it became greater than 75, the while loop will never have known about what happened in the middle. It is only at the very end, or in fact, after the last line of code is run, that it's going to check the value again. So when dealing with while loops, you shouldn't be asking, is the condition ever met? You should be asking, is the condition going to be met once the final line within the loop is run? That's the point at which it does the logic check. Is anything else I want to say about while loops? While loops are good when you don't necessarily know how many loops you want. You just know you want to keep looping until some condition is met. If you knew how many loops you wanted, you would use a for loop. If you have some element you want to loop over, again, you use a for loop. While loop is good when you don't know how many, when there isn't something you want to iterate over and you don't know how many iterations you want to do. Okay, that is it for this file. I'm going to move on to funcs.py. Okay, I may try and speed this up and essentially rely on you using the video and potentially Googling some things you don't get, because there's actually a lot more I want to get through. Okay, so there's two functions at the start here. Only focus on the argument line for now, or where the function is defined here. See how the kill func now has something between the parentheses, unlike we saw before. Before we just saw empty parentheses. So now we're defining a function and we're putting a value in the parentheses. Why is that? That is because this is what you call an argument. So this allows you to provide a value to the function. Instead of just running the function the same way every time. Yeah, instead of just running the exact same code every time, you can have arguments. By providing different values to the arguments, it gives you more flexibility in terms of what the function is able to accomplish. So this function, kill, only has one argument, person. The createPerson function here has three arguments: name, status, and favorite food. And notice how there's an equal sign by two of these, but there's no equal sign by name and there's no equal sign by person. You use the equal sign in Python when you want to set a default value. So in this case, the default value is set to alive for status, and the default value for favorite food is set to none. Person and name have no default values. This also means that these are required. You must provide a value to the arguments that don't have a default value when you call it. And these ones are optional. You do not need to provide a value, because if you do not provide a value, it will use the default. The other thing is that when you have a combination, so you have some that do have a default value and some that don't, you need to put all of the ones that do not have a default value at the start. So you cannot add like a fourth variable at the end, fourth argument at the end that does not have a default argument. It won't accept that. It would have to be moved to the front with the other non-default arguments. Okay. Let me just think about how I want to go over this. All right, so the kill function here, what does this do? It expects a dict, although that's not explicit, that's just sort of something I'm assuming is going to be provided to it. So sometimes when you're writing functions, there's ways to make the acceptable types of things that you provide. You can make those explicit, or you can just say, this function will technically accept anything, but it's assuming it's a dict, right? So we have person here, and we have square brackets and some index values. So if you remember from the previous file, this is how we index a dictionary. So it's expecting a dictionary. If you provide an integer, it's just going to try this, and then it's going to say, I don't know what this means relating to an integer, and it's going to give you an error. So this is a perfectly fine way of programming, though, especially if it's... what I find is that when I'm coding, I'm generally creating like a script that achieves a function, and I'm the only person that's going to be using it. And so there's like some leeway in what you can get away with, kind of. So if we think back to making your own chair, it's one thing to make a piece of wood that has 4 legs and you can sit on it. And it's another thing entirely to design a chair that can be mass produced and meet safety standards and blah, blah, blah. So, yeah, that's all I'll say. So what is this function doing? It's taking the person that's provided. It's going to check the status. And this equals here checks to see if the value is equal to alive. And there's an if statement here. So this will either evaluate to true or false. It will evaluate to true if this equals this. Otherwise, it will evaluate to false. And equal is the way you do, the way you check if one thing is equal to another thing in Python. So the single equal sign is like it's assignment. The single equal assigns the value on the right to the value on the left, whereas equal checks if one value is equal to another. So always use two equals when you're doing logical tests. So if the person's status is alive, the person's status will be changed to dead because the function is kill. So we're killing this person. And then it's going to set message, a variable, equal to some f string, else. So remember, we started this with an if statement. So if this evaluates to true, this indented code runs. Else, so if this did not evaluate to true, this indented code will run. So this code will run or this code will run. They cannot both run. Yeah. So then finally it ends by printing whatever the message was equal to. Create person is just going to take input variables, name, status, favorite food. It's going to create a dictionary. Remember, the curly brackets are how we declare dictionaries. Then there's 3 keys and 3 values in this dictionary. Name is going to be set to name. So there was an input argument called name, and that is what is going to be put here. It's not a problem that these are the same. It's not a problem that name is here, name is here. And it also doesn't have to be that way. This could have been something else. Like this could be like person name, for example, and then this would be person name. But I just happened to make it name. That's fine. Okay, and status, colon, status, same thing. The key, which is like status, the string status, will return whatever value the variable status corresponds to. And then favorite food. And then once that dictionary is created, that dictionary is called person, this function returns person. Then here I have a list of dictionaries. So I just have people. You'll notice these people don't have the favorite food thing. They just have name and status. So this person's name is Billy. This person's status is alive. That's one dictionary. Then there is a second dictionary. So this is a list with 3 elements where each element is a dictionary. Now we are going to loop through this dictionary. Remember, it's a 3-element dictionary, so this loop will run 3 times. Each time, it's going to print person status. Now we have a for loop again, and instead of looping over a variable, we're going to do a specific number of loops. The way you do that is through the range function in Python. So range is a built-in function in Python. And it takes 1 argument. Maybe there's optional arguments, but if you just provide 1 argument, it's going to return a list of that length. Or I don't think it's quite a list, but it's like some type of object that's similar to a list. It's basically going to return a thing that has 10 elements. So if you know I want to do something 10 times, I want to do something 100 times, if you say for any variable. So for variable in range, and then the number of iterations you want to do, that's a way you can do that. So in this case, we're setting we're using I as the variable that's going to be set to each element in range. And you'll see in here, I have an f string and I have I between curly brackets. So if you remember how f strings work, I is going to, whatever the value of I is, will be put inside of this string. And what this line here is doing is it's making a new person using the create person function we made before. And we're providing a value to the name argument, and we're providing a value to the favorite food argument. So, yeah, we'll go from there. So, yeah, so you see the second line here. Actually, I shouldn't change that because you guys have a different file. Okay, so the second line here is commented out. It's an alternative way to do this function. So you see how in the top line here, we say explicitly within the arguments that are inside the parentheses here, we say name equals and then some string. Whereas in the second thing, we don't say name equals. We just put that string as the first argument. So if we look at the where the function is defined, you'll see there's an order to it, right? There's an order to the arguments. The first one is name, second one is status, third one is favorite food. So you can rely on that order and not put the name of the arguments, or you can explicitly put the name of arguments, in which case the order wouldn't matter. So I have name here first, but since I was explicit and in saying name equals string, I can move this to the end of the function call if I want, because when you explicitly state what arguments you are using, you don't need to respect order. But here, I do not explicitly state what I am doing, so I am relying on the order. So there's actually one missing because I only provided 2 arguments here. This won't work. Actually, it technically would work, but it would work because what it would do is it would say, okay, first argument is this string, and then it would go up here and would see what is the first argument. Oh, name is the first argument. So because name is the first argument, it gets the first value. Second argument is status. So we are providing, we're providing 2 arguments. We will use apples as the value for status. And then the third argument, we will use the default value since nothing was provided. That's how this line of code would run. But we're not going to worry about that. We're just going to leave it commented. I just want to introduce this idea that there are different ways to provide values for arguments. There's position, or there is explicitly naming the arguments. Okay, so we're using this one, create person. We set name to a value, we set favorite food to a value, and then we run this function, and then we take people, which is the list we defined earlier, and we're going to append some value to people. So append is a method you can use with lists. What it does is it takes a value and it puts that on the end of the list. So whatever we are appending will become the new last value in the list. Then we're going to print the length of the list. Then some other stuff. But let's run the code for now and see what it looks like, and then we'll cover the rest. Okay, so what are we seeing here? So first it says alive, 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 then it says 13. So where does alive, alive, alive come from? It comes from here. We looped over people. People was this list of length 3. There's 3 elements. Each element is a dictionary. And we are indexing the status of those dictionaries. So person is going to be set equal to this dictionary the first time, the first time this loop is run. Then we are giving the key of status. That returns the value of alive. Then alive is printed. Then we move on to the next dictionary and do the same thing. So alive is printed 3 times. Then it prints 13. So first we started with people. We started with 3 people in our list called people. Then we looped through this thing 10 times. Each time it added a new person. Then we said print len people, and then it said 13. That is because at this point in time, at the time that this code is run, people had length of 13. And len is a built-in function in Python that will return the length of something. So since it started with 3, we added 10 to it, it became a list that had 13 dictionaries. So when we print len of that list, it's going to print 13. Okay, and then a bunch of people got killed. So why did a bunch of people have to die? It is because of what is going on in the rest of the code that I did not yet cover. So first I set I equal to 0. And then again, I'm looping over the people. So remember, people is a list with 13 elements. So this loop will run 13 times. And then what's happening is there's an if statement, and we are doing a logical test here. So the logical test is checking if I is an even number. So this percentage sign in Python is the modulo operator, which is just remainder in division. So if you divide 11 by 2, yeah, Applesauce is meowing at me. That's my cat. Okay, so if you divide 11 by 2 in Python, or sorry, if you do 11 modulo 2, it's going to divide 11 by 2, which is 5, remainder 1. So modulo is going to check the remainder, it's going to see it's 1. In this instance, we're doing I modulo 2. So we're dividing things by 2, and we're checking if the remainder is 0. So if you divide an even number by 2, there will be no remainder. If you divide an odd number by 2, there will be a remainder of 1. So this if statement will be true when I is even. So the indented line of code will run whenever I is even, and it will not run when I is odd. So first I is 0. Yeah, first I is 0. 0 counts as even, and then so that if statement evaluates to true, and then person is killed. The 0th person is Billy, so that's why it says Billy is killed. Then Angela is speared, and Samantha is killed, and so on. So that's what's going on there, and you'll see one extra crucial thing to make this work is we have I plus equals 1. Yeah, I plus equals 1. And what this does is it takes the existing value of I and it adds 1 to it. Remember before we did minus equals, now we're doing plus equals. So this is the key to making this loop work, because otherwise I would just be 0 every time and it would say it's true every time. So by increasing I by 1, we get through the 13 elements and set I equal to a number that corresponds to each element. Then we have something called list comprehension, and we're running low on time, so you can Google how list comprehension works and try and figure out what's happening here. Google Python list comprehension. I literally got through like half my material. I did not realize how long this was going to take. Yeah, so I'm going to stop there. And unfortunately, I didn't get to anything involving pandas, which is it's like a data analysis library in Python. Um, I'm not sure yet how I should proceed with that. So one option is I can just record myself doing this with the second half of my material, and then I can send it to you guys. And if you're interested in learning Python, you can go through that. Or we can just leave it there also, and you can okay, record yourself. Kanan says, yeah, I'll probably do that. But how about in addition, you guys? I mean, you're free to ask questions now, but also if there's anything I went over that was particularly unclear, like I realize obviously if you've never seen Python before, like I went through a lot. That's kind of the point, but at the same time, I know there's going to be things that are unclear. Um, but if yeah, so you can also email me any questions or anything you would like to see clarified, and then when I do the second recording, I can try and cover those essentially, and then I'd move forward from there. Can I go on Zoom for questions? Yeah, let me put my headset on. What I'm gonna do? Yeah, I'm actually gonna just stop the stream now. So any questions you have at this point, we'll do them on Zoom.